Hello students, welcome to the interesting chemistry. In continuance of the redox reaction, it is my fifth video and I frankly speaking that it's the leftover part of the fourth redox reaction or the fourth video about the redox reactions. So in my fourth video I explained all the three questions and these three questions. These three questions I have told you, and now I will tell you about the fourth question, that calculate the oxidation number of these compounds or ions. There is a paradox of the fractional oxidation number. I have added here two examples, C3O2 and Br3O8, and what is stop notation, so I will tell you about this all in this video, so please watch this video from start to end. Let's, without wasting any time, start the video. Calculate the oxidation number of the underlined elements here in ClO4. One negative, calculate the oxidation number of chlorine. So here I told you in my previous video, I told you for in a monoatomic ion, the charge of the ion is called the atomic number of that ion. Suppose this is Cl minus, then the oxidation number of Cl is -1. If it is Ca double positive, the oxidation number of Ca will be +2. Al triple positive, the oxidation number of aluminium will be +3. So in this way, in a monoatomic atom, the charge of the ion is called the atomic number. So if charge is minus, so the atomic oxidation number will be minus. If charge in a positive, then the oxidation number will be in positive. And in polyatomic ions, the sum of the oxidation number of ions is equal to the charge of the polyatomic ion. So here the total of the sum or total of the oxidation number of chlorine and oxygen is equal to the sum of the chlorine and equal to the charge of this polyatomic ion. So here, how will you, suppose you want to calculate the oxidation number of Cl, so you put here X plus, there are 4 oxygen, so you can write here 4 into -2, as I told you in my previous video. So L.42 and is equal to. In compounds I have written here is 0, but now you have to write here -1 because the polyatomic ion has the charge 1 so you will put here that -1, and X plus -8 is equal to -1 and X is equal to +7. Here the oxidation number of chlorine is +7. In NiCO4, in my previous set of rules, I didn't tell you about the addition of the reagents. When some reagents are attached, like a water molecule, ammonia molecule, and carbon monoxide, these reagents always consider the oxidation number as 0. So if you write, suppose here CuSO4 5H2O. So if you want to calculate the oxidation number of copper, so you will write X plus sulfur. Sulfur is always -2, and oxygen 4 into -8. So here, sorry. you can calculate like this. So this is sulfate. This is sulfate. So here you can write here -2 and plus for 5H2O. It is 5H2O. So you can write here 0. If suppose there are CuNS3,4 and SO4, so on. So here NS3 is addition. You will write here 0 for NS3,4. So here in this way, here in NiCO4, CO4 will be considered as 0. So the oxidation number of X plus 4 into 0 is equal to 0 and X is equal to 0. So here, P4 triple negative X, the oxidation number of P is X and O is 4 minus 2. 4 minus 2 is equal to 0. So X is equal to P4. Oh, sorry. There are 3 negative. If you will write here 0, then it is wrong. You will have to write -3. So X is equal to -8 is equal to -3 and X is equal to 5. X is equal to 5. Am I right? Again, I am doing some mistake here. I should write here +5. +5 because oxidation number is written with the plus minus sign. So again, S2PO2 minus H2PO2, S2PO2 minus, calculate the oxidation number of P here, H2. The oxidation number of H is always +1. So here 2 into +1, P is equal to X. And O2 2 into -2 is equal to -1. Here -1 is there. So the oxidation number of X is equal to 2. Right here 2 plus X minus 4 is equal to -1. So here X is equal to, I think, minus plus 2 minus 3, X is equal to -1 plus 4 minus 2, so here plus 1. In this case, the oxidation number of dihydrogen phosphide negative here is equal to 1. And now come to the case last, and sodium thiosulfate, sodium tetrathiosulfate Na2S4O6. The name of this compound is sodium tetrathiosulfate. Tetra means 6. So the Na2, tetra means 4, sorry. Na2S4O6 tetrathionate S4 tetra. So the number of, what is the oxidation number? What will be the oxidation number of S4? So you write here 2 into +1 plus 4x plus 6 into -2 is equal to 0. It is 0. Then 2 plus 4x plus -12. -12 is equal to 0. 4x is equal to 12 minus 2 is equal to 10 and x is equal to 2.5. X is equal to 2.5. This is a new problem. Electron. This is we assume that the transfer of electrons are the oxidation number. We assume in the previous video in the electron transfer in the ionic compound, the loss of electron or the gain of electrons are called the oxidation or reduction. So electron can't be divided. So here 2.5 electron. So it is wrong. So again I have mistaken here. Right here +5 plus 2.5. So it is a fractional oxidation number. It is a fractional oxidation number. So I have written here paradox of fractional oxidation number. Here I have told you this is a paradox. What is fractional oxidation number? So the fraction, when there are two or more atoms of the same element in a compound, so it is not necessary that all the atoms of that compound are in the similar oxidation state. What I am saying to you, please try to understand. When there are two or more atoms of the same element in a compound, it is not necessary that all the atoms are in the same oxidation state. So here there are four sulfur atoms. So it is not necessary that all the four sulfur atoms are in the same oxidation state. It can be revealed by the structure of that compound. So take the structure of the S4O6. What is this? This is the S. This is S4, 4SR. Here, this is the S4, and now this is S4O6. This is 2 oxygen here with double bond, 2 oxygen with here double bond, 2 4 here double bond, 1 oxygen is here and 1 oxygen is here. This is the structure. You can write here minus, and this is, you can write here minus because here it is Na. Here it is Na. Here Na2S4O6. This is the structure of Na2S4O6. So you should write the structure of Na2S4O6. This structure will tell us about the actual oxidation number. In this, the oxidation number, this S, what it will be the S? This is, suppose this is the 6. Here, come to this here. The oxidation number, this electron, there are 3 bonded pair of electrons that are located, situated in the middle of the sulfur atoms. So the oxidation number of this S will be 0. The oxidation number of this S will be 0. Here this will be 0. Now this is SO3 and this is SO3. There are this S and this S. This the oxidation number is 5, and this the sulfur, this oxidation number. The oxidation number of this sulfur is +5, and the oxidation number of this sulfur is +5, and the oxidation number of this sulfur is 0, and this is also 0. Now this is both the 4s has the total of the 10. Both the 4s has the 10. Then the average value of the sulfur, the average value of the oxidation number of the sulfur will be +2.5. Now I have told you that this is SO. So this is S4. Sorry, this is SO3. This portion is SO3. This is SO3, 1 negative. So calculate X minus 3 minus 2. Sorry, X plus 3 minus 2 is equal to -1. This portion is SO3, so X plus 3. There are 3 options. 3 minus 2 is equal to -1. So X is equal to +5. X in the same way, the oxidation number of this sulfur is +5. In this way, the whole as a average there are 4s, and the total oxidation number is 5 plus 0 plus 0 plus 5 is 10. So S is equal to 2.5. The oxidation number of S is equal to 2. This is the average. This is the fractional oxidation number is the average of all the atoms found in that compound. So it is the paradox. So I have told you about the now I am taking another example. Now I am taking another example here. What is C3O2? It is carbon suboxide. The name of this compound is carbon suboxide. So here this is C3O2. Now here 3x plus 2 into minus 2 is equal to 0, and 3x is equal to 4 and x is equal to plus 4 by 3. So the oxidation number of carbon in this compound carbon suboxide is 4 by 3. 4 by 3, it is also a fractional oxidation number. Now so to know about this, there are 3 carbon atoms. You should go into the structure. What is the structure of C2O3? It is the structure double bond, C double bond, C double bond O and double bond O. It is the structure of C3O2. Here, in this case, this oxygen, this carbon, because this carbon is placed in the center, so the oxidation number of this carbon is 0. Oxidation number of this carbon here is 0, and here in this case here the oxidation here this both the electron are here delta positive and here delta negative, here delta positive and here delta negative. This oxygen is minus 2, this oxygen is minus 2. So this oxygen, what will be the oxidation number? This is we have calculated the oxidation number here. So here x minus 2 is equal to 0. So x is equal to plus 2. So here the x is here. So again you can calculate both the carbon. 2x is equal to so again 2x is equal to minus 4. So x is equal to minus 2. Again we can say that surely 2x 2 into minus 2 is equal to 0. So 2x is equal to plus 4 and x is equal to plus 2. So the actual number of the oxidation number of carbon is plus 2. The actual. How can you? So in this case, there are this oxidation number is this minus this one and this one. So here this x and this x has the oxidation. This is 0. So it is the average of the 3 carbon atoms. Now come to the structure of Br3. What is this structure of Br3O8? What is the structure of Br3O8? There are 3 bromine atoms. There are 3 bromine Br. All the bromines are bonded with single bond like this. These are Br. And bromine has, say B, it is BrO3. BrO3. It is again Br. It is again Br. Again O and again O. This is the structure of bromine. So here we will find Br3O8. Br3O8. So 3Br plus 8 into minus 2 is equal to 0. So 3x minus 16 is equal to 0. So the x is equal to 16 by 3. So here again the oxidation number of the bromine is 16 by 3, but here this structure shows us that this is so here both the bromine, these bromine are have some different are in different oxidation state. So the average of the oxidation number is 16 by 3. You can write this bromine has -6 and this bromine has -6 and this is -6. This is -6. Sorry, +6. This is +6. So here this is again +6 and this is +4 because 2 here 2 this is 2 and 6 electrons are transferred to the other 6 electrons. It is 6 +6 and this is 4. So here in this case you can tell us with this structure we can reveal the actual oxidation number. So always when a fractional oxidation number is you found then tell or give the structure to clarify to define the fractional oxidation number. So I told you about the paradox of the fractional oxidation number. In the last Stokes notation, write the Stokes notation of these compound, these formula. That what is this no? But it is a question. Suppose you are given that write this AuCl4 in the form of the Stokes notation. You don't know what is the Stokes notation. Since there is a scientist that is Albert Stokes, he gave a new notation to write the formula of the transitional elements, because transitional elements are found have the different oxidation number, a variety of oxidation. They are the interchange 2 to 7, 2 to 8. Any manganese has the maximum oxidation number. So here, how will you write? Suppose this is CuSO4. If you change this, here the oxidation state of the copper is 2, Cu plus 2. So here, so if you write here in second, you will write here Cu second or SO4. If this second shows this second shows the oxidation state of copper. This is the oxidation state. So this is the Stokes notation of this is the way to write the Stokes notation of the formula of any compound. Again, so how will you write here? HAuCl4. So here this is the transition element. So you should know what is the oxidation number of this Au. Au means all, whether it is all or bold Au. So calculate +1 x plus 4 minus 1 is equal to 0. So x is equal to +4 minus 1 is equal to +3. So here this AU is in the form of third. Here, right here, third. AuCl fourth. Here you will write third. You can write here third in this way. So here you write third AuCl. This is the oxidation state of the Au is 3. It is in the ionic form. In here Fe2O3, Fe2O3. Here the oxidation Fe is in the form of Fe3 and It is the Stokes notation of Fe2. The oxidation state of Fe here is 3. So the plus 3. So you can write here Fe3O3. MnO2. And 2, 4 minus. So here you can write Mn4. Mn4O2. This is the way how to write the Stokes notation. So I told you about this. So now I am going to tell you about the oxidation. How will you identify with the oxidation number whether it is a oxidation reaction, whether it is a reaction? When the oxidation number increases in a reaction of an element or of an atom of an element, then it increase of the oxidation number, it is oxidation, and decrease in the oxidation number, that is a reduction. So now I think that you have understood all about the oxidation and reduction. In the last, I am going to tell you about what is the difference between valency and the oxidation number. Valency, suppose here you say the valency of sodium is 1. The valency of sodium, the valency of sodium, valency of Na is 1. Valency of Na is 1, and the oxidation number of sodium is also 1, but the difference is On is 1. On is 1. So plus 1 and here. So valency is always a number 1, 2, 3. That or the valency of chlorine is also 1. Valency never be denoted in plus or minus. Valency tells us the valency of an element tells us the number of hydrogen which is replaced by an atom or combined by an atom. The number of hydrogen replaced by an atom or combined by an atom, that is called valency. But oxidation number is different. So here valency is 1, maybe 1, but oxidation is represented or denoted by plus or minus. Again, valency of the valency of the number, but the oxidation number may be varied. The valency of carbon. Valency of carbon is all 4. The valency of carbon is 4. But the oxidation number varies from 4 to 4. Suppose we take CH4, CS3, Cl, CS2, Cl2, CSCl3 and CCl4. Here the oxidation number of carbon is -4. X plus 4 into plus 1 is equal to 0. So X is equal to -4. In CH4 methane, the oxidation number of carbon is -4. Valency will be always 4, but here is 4. Here there are 3 hydrogen and 1 chlorine. The valency are all the 4 valencies are occupied by the 4 hydrogen, 3 hydrogen, 1 chlorine. Or in all formula, the valency of the carbon is 4. All the 4 valencies are occupied by hydrogen, 2 hydrogen, chlorine. You can take it, CCl4. All the 4 valencies are occupied by the 4 chlorine atoms. So the valency in all compounds is 4, but the oxidation number is different in all compounds. Here in this case, the C is equal to minus, the oxidation number is -2. Calculate +3 - 1. Here 0. The oxidation number in this Cl2 is 0, and again here the -2 plus 2, and here in this case the plus 4. The oxidation number of carbon in methane minus 4, CS with minus 2, here 0 and here is plus 2. So this is the difference. So I have told you the difference between the oxidation number and valency. That's all for the reduction. Now I will tell you about the balancing of the ionic equations. The equation, how will you, with the help of the electron, with the help of the electron transfer, or with the help of the oxidation number, I will tell you the very simplest